Okay, this is section 1.6. We're going to be solving linear inequalities. We've already done linear equations, so this time we're going to do inequalities instead of equations. The homework assignment, 66 through 88. Inequality symbols. We call this symbol right here, we say that is the greater than symbol. And if we put a line underneath it, we can say it's greater than or equal to. This is less than or equal to. All right, suppose we want to graph an inequality. I know in the past when you did number lines and you did your graphing, and let's suppose we have the number 3 and we want to be over here, you did the shading. Most of you are familiar with open and closed circles. We've chosen not to do that in this class. We're not going to do open and closed circles when we are graphing. There is a reason for that, and I'll talk about that reason in a minute. So instead of doing open and closed circles, we're going to do parentheses and brackets. So where you'd put a closed circle, you're going to put a bracket, and where you'd put an open circle, you're going to put parentheses. So here we have x is less than 8. So in the past, you would have put an open circle at 8 and then shaded to the left. We want to be smaller than 8. That's these numbers over here. Well, the new textbooks, instead of doing an open circle, they actually use parentheses. So instead of an open circle, you're going to use parentheses. And the parentheses should open surrounding the shading. Okay, so if you're shading this way, you want to open this way, not that way. Okay, so that's not what you want there. Suppose we have x is greater than or equal to 3, and I want to graph it on a number line. So I don't care if you put 0, 1, 2, 3, but I do need to see the number 3. X is larger than 3, so larger than 3 is going to go in that direction. Greater than or equal to, again in the past you would have put a closed circle, but I am going to have you put a bracket, and the bracket should open surrounding the shading, okay? So don't open your bracket that way because we're shading this way. This would be wrong. X is less than 1. We need a 1. We want to be smaller than 1. That's this direction. It's less than. There's no line under it. No line under it, which means parentheses. All right, let's take a look at example 3. We have negative 8 is less than x is less than or equal to negative 4. Notice the x is in the middle. When the x is in the middle, we're going to be shading in the middle. So I need a negative 8 and I need a negative 4, and I need to shade in between those two numbers. The x is in the middle, the shading is in the middle. Now, with the 8, we had negative 8 is less than x, so that's parentheses, and you need to open your parentheses in the direction of the shading. And for the 4, we had that less than or equal to, that would make a bracket, and we need it to open in the direction of the shading. Example 4, I'm going to have you try that one on your own. Okay, interval notation. You probably have not seen interval notation before, but this is actually why we've switched, instead of open and closed circles, we've switched to the parentheses and brackets, so it actually matches interval notation. So interval notation is just another way, instead of doing graphing on a number line, we would do interval notation that gives you the same information. It's just another way of writing it. The numbers are the endpoints of the interval. The number on the left is going to be the smallest number. The number on the right is going to be the largest number. Parentheses, if I would use a less than or greater than or open circle, that's when we use the parentheses. And wherever you would use a closed circle or equal to, if it says equal to, that's when we use the bracket. So we're going to go back to examples 1 through 4, and we're just going to write these in interval notation. Now, the advantage to when we did the number line, so our number line looked like, so we had 3 and we had a bracket and we shaded this direction. The advantage to using the bracket is, notice I have shading to the right and I've got this 3 on the left, so I'm going to put a 3 on the left. Now when the shading keeps on going, I'm going to say, and it's going in the positive direction, I'm going to say positive infinity on the right. This was a bracket, so the 3 gets a bracket, and infinity actually always gets parentheses. So let's take a look at example 6, which we've already graphed. So we had 1 and x is greater than 1, although I think I might have changed this in your notes. I apologize if I have a typo in the notes. So we're going to do the way I have it on the board. X is greater than 1. Greater than 1 is going to the right. Greater than was parentheses. All right, so let's change that to interval notation then. The 1 is on the left side of this interval that keeps on going. So put 1 on the left, that would be the smaller number. Keeps on going in a positive direction, that's positive infinity. Infinity always gets parentheses, and the 1, we had parentheses on the 1, so here's our interval. And again, like I said, I do believe that is different in your notes, and I apologize if it is. All right, we had -8, we have -4, and we shaded in between. We put parentheses on the 8, and we put brackets around the 4. So let's take a look at how that would look in interval notation. The -8 is on the left, the -4 is on the right, the -4 had a bracket, and the -8 had parentheses. I'm going to have you try to do example 8 on your own. Let me know if you have any questions. All right, so now I have an interval notation. I want to graph it. So number line, -3 is on the left, so I'm going to put -3. This is positive infinity on the right. Positive infinity means keep on going in the positive direction. These are parentheses, opening that direction. Example 10. We've got 9 on the left. We've got 12 on the right. 9 has parentheses. 12 has a bracket. And so 9 has parentheses, 12 has a bracket. And whenever we have them opening this direction, it means shaded in between. So we're going to shade in between. Okay, so let's suppose I ask you to solve a linear inequality. The important thing to remember when you're solving an inequality is that when you multiply or divide by a negative number, negative number, not positive, notice, when you multiply or divide by a negative number, you have to flip the inequality sign. Don't forget to flip the inequality sign. There will be one of these on the test, and a lot of people get this one wrong because they forget to flip. Suppose I have an inequality, -x is less than 4. There's a couple different ways we can solve it. In this first example, I chose to add x, and subtract 4, and I end up with the -4 on the left and the x on the right. Now, generally when I write our answer, we put the x on the left-hand side. Trust me, it makes things so much easier. And you know, the point is towards the number. So make sure when you put the x on the left and the number on the right that you do flip that sign. So let's look at example 11. I have 9x minus 11 is greater than 8x minus 14. Do your best when you combine the x's, or not combine, but put them on the same side. Do your best to make the x's positive. It'll make your life easier. So what I'm going to do is I'm going to, instead of subtracting 9x, that would give me a negative x, which we don't want. I'm going to subtract 8x. Subtract 8x. If I take 9x and subtract 8x, I have 1x left over. Notice I did not flip the sign because all I'm doing is adding or subtracting. You don't flip the sign when you add or subtract. I'm going to get the 11 to the other side, so add 11 to both sides, and I have x is greater than negative 3. Graph the answer. I've got negative 3. We want x to be bigger than negative 3, so that means go to the right. It's greater than is parentheses. So that's what it would look like as a graph. Interval notation. I have my negative 3 over here on the left, and it keeps on going to the right, which is positive infinity. The negative 3 had parentheses, and infinity always gets parentheses. Okay, let's take a look at number 12. Okay, when you have a fraction times the variable, easiest way, instead of dividing by 1/6, it's a whole lot easier actually to multiply by the reciprocal. So what I'm going to do is I'm going to multiply both sides by negative 6. Multiply both sides by negative 6. But notice I'm multiplying by negative. That means this sign has to flip. So when I multiply negative times negative, I get positive, and negative 6 times a negative 1/6 gives me a positive 1x. In other words, those cancel out. The sign has to flip, and 3 times negative 6 is negative 18. I'm going to graph it. It's greater than, we're going off to the right. Greater than is parentheses. Interval notation. Number on the left is negative 18. Keeps on going to the right, that's positive infinity. And the 18 had parentheses, and infinity always gets parentheses. Okay, example 13. First thing I have to do is distribute the negative 5. Negative 5 times 4x is negative 20x. Negative 5 times 13 is I have no idea. Let's see if I can't multiply that real quick. 65 is less than negative 25x minus 35. All right. The x's have to be on the same side. Now remember, we want positive x's. So you're better off adding 25x to make the x positive than adding the 20x. So I end up with positive 5x and add 65. I get 5x is less than 30. Divide by a positive 5. I do not need to flip. I'm dividing by a positive number. X is less than 6. So I've got my graph. It's less than, so I'm going off in this direction. And I need parentheses. All right, so if I'm going off to the left, going down, that's in the negative direction. I need negative infinity on the left. My 6 is on the right side of the interval. And they both, infinity always gets parentheses, and the 6 had parentheses. All right, I'm going to stop here and create a two-part video. So I'll stop here and create the second part. So hold on.